So the net effect of regeneration and repair is how you get growth. So you can have net positive growth and net negative growth. So regeneration will contribute to positive growth, and apoptosis will contribute to negative growth. So the positive growth of the organisms, where you have an imbalance of regeneration and apoptosis in favor of regeneration, so new cells forming. Whereas net negative growth will be an imbalance in favor of apoptosis, where you are losing more cells than you are regenerating. So there are also extreme bounds. There's too much growth, and then there's too little atrophy, and then there's too little negative growth. So too much positive growth will be hypertrophy, where you have thickening, and eventually thickening to the point where the function is less so. Less good? Sure. Where your functioning is worse. There we go. That's English. All right. And the reverse of this, where you have too much net negative growth, that's atrophy, where you are losing more cells to the point where function is impaired. Now, all of this hypertrophy and atrophy, as per usual, is Greek, because it's always Greek. So, I want to remind you guys, mitosis is for regeneration, and tissue growth needs to be very high fidelity. So that's actually one of the things that mitosis is for. It's for regeneration of tissues. It's for high fidelity copying of making high fidelity copies of cells. It's for maintaining a certain number of chromosomes, and is for maintaining the correct number of chromosomes, I should say, and also for creating genetically identical daughter cells. Now, here's the problem. If your cells don't match, you have a system in place that we will discuss in much more detail in Unit 5 that will destroy any cell that it finds, or any life form that it finds, or anything, any protein or macromolecule that it finds that doesn't fit, that doesn't belong here. You don't belong here, we will kill you. That sort of a deal. The cells have this major histocompatibility complex. It's like an ID card. They flash it and say, I belong here. I belong here, I was born here, this is where I'm from. These are my MHC antigens. They exist on my cell surface membrane. You can test them out for yourself as much as you like. And then the macrophage comes along and is like, I'll be the judge of that, and it just starts touching all over the cell's face, and it's like, you're good, move along. But then it finds a cell that it doesn't think belongs there. And it's like, hold on, this bump right here, where'd you get that? Nowhere, officer. Oh, I don't think you belong here. Kills it and engulfs it. Your body doesn't play. Your immune system is hard frickin' core. So that recognition, the cellular recognition, that is the MHC antigens, the major histocompatibility complex. Major because it's important, it's big. The histocompatibility, it's the compatibility of the tissues, because histo, once again, is Greek for tissues. And it's a complex, not like the relationship status on Facebook, but complex as in a couple of things pieced together, a bunch of different stuff pieced together. So that's the major histocompatibility complex antigens that are functioning as your cellular ID. Hey, I belong here, don't eat me. Now, let's talk about babies versus clones. And yes, I know, it's not a clone trooper, it's a stormtrooper. Comments, doobly-doo, all right? Yeah, you blast me later. But if you're a stormtrooper, of course you'll miss. All right, so before you get excited, the reproduction I'm referring to here is not sexual reproduction. I am going to be talking about asexual reproduction. So A is referring to without, none, or not. And the reproduction part, well, you're familiar with the reproduction part. So essentially, this can exist in a number of forms. The usual result of asexual reproduction is a clone. So a clone is a cell a product, a cell product, or an organism that is genetically identical to the unit or individual from which it was derived. So a clone is not a specific term for a complete organism derived by cloning techniques. It is not Dolly the sheep. She was a organism produced by cloning techniques. So yes, a clone of sorts, but a clone is a non-specific term for a population of cells that's derived from the same ancestor cell. So if you really want to play with this terminology and really rules lawyer this, you could state that you are in fact a clone of yourself. Like you are a group of cells that are derived from the same origin cell. That origin cell being the original cell that was the egg meeting sperm combining and then starting to divide. So that combination part, that was the clone. So, can you pause for a second?